We saw this a little bit last semester. We know that a rational exponent corresponds to a root. So the 1 over n power of a just means we're taking the nth root of a. And more generally, if I have any old fraction exponent, the denominator tells me what root I am taking, and then that numerator tells me what power I'm raising it to. And if you're working with especially positive real numbers, or in particular, if you're working with real numbers, it doesn't matter which one of these, in what direction you work. Like if you decide to raise to the m first and then take the nth root, or if you decide to take the nth root first and then raise it to the m power, it'll be the same result. So let's do a little practice. We could do this all without our calculators, at least these first few. 27 to the 2/3 power, I'm just going to rewrite this. This means I'm taking the cube root of 27 and raising it to the second power and squaring it. Yep. Now, the reason I'm doing it in this order is because 27 is a perfect cube, so that part I can do in my head, and then the result is easy to square. If I squared it first and then took the cube root, I'd have a hard time doing that without the help of a calculator and maybe making some mistakes along the way. So the cube root of 27 is 3, and 3 squared is 9. Easy peasy. Nine to the negative 3/2. Well, we have a fraction exponent and it's negative. I'm just going to deal with that negative power right off. If I have a negative 3/2 power, I know that means 1 over 9 to the 3/2 power. And the 3/2 power, what does that mean? What are we doing?
Finding the square root of 9 cubed.
Yeah. So I'm going to do it in that order again because I can do it in my head without making a few mistakes and then frustratingly grabbing the calculator. So the square root of 9 is, of course, 3. And we have 1 over 3 cubed, or 1 over 27. Let's do some more. 8b to the negative 4th times c squared, all to the 4/3 power. So there's more than, well, I keep saying this, but it's true, so I don't mind that I keep saying it. There's more than one correct first move that we can make. You can get the same correct answer at the end by following sort of different sequences of steps. I would start this one out personally just by, I think, rewriting this. That b to the negative 4, just rewrite this stuff in the parentheses as a fraction. I know I've got a b to the 4th in the denominator, and up top I have 8c squared, and this is all to the 4/3. Now, if you had started off by just distributing the 4/3 power to everything in the product, that's fine. You'll get the same answer eventually. But I'm going to distribute that exponent now. I've got 2 factors up top and 1 factor in the bottom. Each of those things are going to get that 4/3 power. We have 8 to the 4/3 times c squared to the 4/3 over b to the 4th to the 4/3. What's 8 to the 4/3 power? Can anybody do that without a calculator? How would we start it without a calculator?
32?
I don't think it's 32. It is 16. How do you get 16?
Take the third root of 8.
Yeah.
And then
Cube root of 8, and then we're raising that to the 4th power. And that'll eventually get us 16. Okay. What about c squared to the 4/3? What property are we going to use? I've got c squared, that exponential expression, raising that to a power.
Did you add the exponents?
Nope, but you're on the right track.
Multiply?
Yeah, we multiply those exponents. So we have c to the 8/3. And likewise on the bottom, b to the 4th to the 4/3 would be b to the 16/3. And I think that's as far as we can go. Questions so far? Okay. Oh boy, this is another good one. How do we start? Well, let me say this again. There's many correct ways we could start, right? Different sequences of steps we could take.
Maybe the b with the negative exponent with the denominator.
Yeah, and I think, more generally, if we came at it from just simplifying the stuff in the fraction, that might make, we'll have fewer things to which to distribute that negative 1/2 power. So we've got a to the 5/6 over a to the 2/3, and then we have b squared times b to the 1/5. That's what you were talking about, right? Bringing that b to the negative 1/5 down in the bottom. Now, we have two things to deal with. We have this product, b squared times b to the 1/5. What do we do with exponents in that scenario? Yeah, we add them together. Yeah, and then we have this quotient. So the exponents on a we have to subtract. So I'm just going to do a little arithmetic on the side, I think. So 5/6 minus 2/3. This will give us the exponent we need on a. We need to get a common denominator. This is 5 minus, this will just give us 1/6. And then adding the 2 plus 1/5. That common denominator will be 5. So we have 10 plus 1, or 11/5. So, and this is all to the negative 1/2. So these both end up being positive, right? And what that means is, in particular, this stuff on the 11/5 is positive, but that product was in the denominator, so that's a b to the 11/5 on the bottom. When we subtracted 5/6 minus 2/3, we got a positive 1/6. That means we're left with a to the 1/6 up top. Already it's looking a little better. What do we do now? Yeah, you can distribute the negative 1/2. You could also, and I want to just point this out because it might be occasionally a route you want to take. I could rewrite the whole fraction to the positive 1/2 if I do what? Yeah. And the only reason why this is sometimes a convenient step to take is because it helps us take care of the whole negative exponent thing right at the get-go. And now, we still have to distribute the powers. So we have b to the 11/5 to the 1/2 power over 4 to the 1/2 times a to the 1/6 to the 1/2 power. What should we get on top? Mm-hmm. What's 4 to the 1/2? 2. And what's our power on A? Yeah. Now what? I mean, other than, of course, another one. What do we do here?
Could start getting rid of a negative exponent.
Sure. Yeah. So, how do you want to write the first term here?
1/4
Mm-hmm. And the second one?
-3/x².
Mm-hmm. Great. We're in good shape. Next.
Distribute the 1/2.
Yeah, through that first denominator. Yep, so we have, let's see, 4 to the 1/2, x to the 4th to the 1/2. And then obviously we're going to want to simplify those. So 4 to the 1/2 is 2 again. X to the 4th to the 1/2, x squared, yep. Yeah, let's do the subtraction. So common denominator will be 2x cubed. This guy's got to pick up an x. This guy has to pick up a 2. So overall we have x minus 6 over 2x cubed. Look at that. So much nicer than this ridiculous expression up here, right? By which I mean, if I were using, first of all, a couple of things. If I were using this expression, to a value, maybe this popped up in some application or whatever, and I just wanted to evaluate it, like I know what x is, what is the expression equal to? I would much rather plug it in here than I would plug it in up there. Also, sometimes of particular interest when you're working with expressions is where something is equal to 0. That'll happen actually a lot in calculus for folks who might take calculus. We are often, interested in where this type of function, we call it a derivative, is equal to 0. And again, if I have an expression in this form, I just look at it. I don't even need to do any work. This is 0 and x is 6, and that's the only place it happens. But that's kind of hard for me to tell in that original expression. So, there's a reason why we call this process simplifying an expression.